In this video, I'm just going to talk over the final solution to the state machine that was uh, developed in the prior video. So there wasn't much left really to do. Um, so what ended up being necessary, or at least in my opinion desirable, was to add another state for bad credentials. Instead of trying to keep track of some particular flag, this is a case where the state of the state machine really does track that particular piece better. So I factored these two events out since they were doing the same thing. So on a logout, we route to the login screen and send the remote logout mutation, fix the user, and on login we call handle login, which is the same thing every time, right? Try to run the login mutation and get the current user back. But then I split the checking existing session and checking credentials out. This was a shared thing before, and I just realized these things really do need to do two different things. And I got an extra feature out of this actually. So when I'm checking the existing session, which comes in from this initial handler, right? We load the existing session, we're checking the session. If we get an OK, well then if we're not logged in, we go to login. Otherwise, we go to the idle state. That's straightforward. And if it fails, we go to the server failed state. All good. The difference for the checking credential state, which is we push into that on login events. So if we have a login event, we handle login, and login always sends us to checking credentials. This state, we've got a couple of interesting concerns. On OK, it could be that logged in is false, and in that case, the state that we should go to is bad credentials. Otherwise, we go to the idle state because we logged in. But the other thing we're interested in is what if the user had tried going to something like the settings screen on their HTML routing path, and we found out they weren't logged in. Well, then we want to redirect them to login, but what you'd like to have is then the ability to, once they're logged in, send them back to where they wanted to go. Right? That's a desirable feature, and the state machines made this trivial to do. So what I needed to do was be able to store my intended desired path. So in the begin, over on the client, we can actually pass in an extra map, and this extra map is the event data for this initial event. So I just pass in desired path, and then I just looked at the window location to find the slash settings portion of that, which is the path name attribute, and sent that in. And then in the state machine, when you get that event data, it only comes to the handler once, right? So you have to capture it. But there's this local store. It's actually just part of the state machine storage, right? It's called local storage, where I can put key value pairs. So I said, under the config key, store the event data, where the event data is just this desired path, right? So I saved that for later routing. I went ahead and did the load of the session, and then went to checking existing session. So once that's stored, as long as the state machine doesn't get restarted or exited, and in this particular case I've set this state machine up to just always be running while the application's running, then that information will be there. Of course, I'm only going to use it once, but so then the trick, well, actually I might, now that I think about it, my login logic probably needs to reset that piece of data, because now if I log out and log in, it's going to take me to settings no matter what. But that's okay. That's easy to fix. So this gave me the power to store that, and then when I saw that the credentials were finally good, I'm logged in a desired path, then I could route there. And so it gave me this nice permanent storage location for that while I'm dealing with did they type in the right password, did they type in the wrong password. And you can see now if I try login and there's a bad password, I get the right thing, and if the server was down, I'd get the different error. So over on the client side in the login form, by the way, the missed refreshes, I just needed to reload the app. The queries weren't refreshing properly from a hot code reload. So once I reloaded it, all the refreshes started working right. So in login form, now I can just get the active state. I can check if that's checking credentials. That means I'm busy. If I'm in bad credentials, that means there's bad credentials, and right. So then I can say the form has an error class when one of those is a problem, and then these will only show up if the form has the error class. So then I can say if if it's bad credentials, show that, and if it's a server error, show that. So again, very declarative, and now I'm only dealing with the state of one thing, the state machine, as opposed to a bunch of twiddly individual values that I've got to keep track of myself and reset back to original values, etc. So I find this to be a much cleaner solution. If you think about like trying to implement that, okay, go to this route afterwards, kind of behavior, the fact that that integrates very nicely in there with the state machine just shows you that there's quite a bit of flexibility here, and hopefully you can also see that this state machine really isn't tied to the UI in any way, shape, or form. Right, the actor abstraction gives me a way to use data from app state or set data in app state without having to actually know what UI components I'm tied to, which then lets me reuse this state machine later when I decide I want other UI components to be involved, maybe in a different application. Right, I can just literally pick this up, copy the code to a different application that has different UI design characteristics, and the state machine will still work for it.